Hi, my name is Emmanuel Chukwemeka, and I'll be taking us through the mesh sort algorithm for my presentation. So first, what is sorting algorithms? Sorting algorithms basically are used to rearrange a given array or list of elements in order. So depending on how you want to arrange it, a certain algorithm helps with arranging your elements in an array. Example could be selection sort, bubble sort, insertion sort, merge sort, bucket sort, pigeonhole sort. But for this presentation, we'll be looking at merge sort. So we'll be looking at how to sort algorithm using the merge sort. Okay, what is the merge sort? Merge sort is a divide and conquer algorithm that sorts array first by breaking it down into smaller arrays and then building up the array together back the correct way so that it is sorted. So here say it divides the input array into two halves. So it continues dividing it into halves and halves until we get to a single element, and then it measures the halves up. So how it does it, just as I said, it splits the array into halves and then it recursively sorts both halves. So it splits it up to it divides the unsorted array into two sub-arrays, half of the original, and it continues to divide it as long as the current piece has more than one element, and then it merges those two sub-arrays together by always putting the lowest value first, and it keeps merging it until there are no sub-arrays left. And this is just an example. So let's say we have an array of 12, 8, 9, 3, 11, 5, 4 in this order. And then we want to sort this array using the merge sort. So this visualization shows us that it first divides the array. So here we have 7 elements. So it divides it into 3 and 4. And then we go again. That's the first step. The second step again, it divides the tree, since it's not an even number, divided into 2 and 1. For the other side, where we see 4 elements, it divides it into 2 elements each. And then we see for third level, the third level, we see that um, 8 and 9 is further divided into individual elements, right? And we also see the same for in the other side, 3 and 11, 5 and 4. Now we are done with the dividing. Now is to merge it up. So how it does that is it follows an order, right? So if it looks at 12 and 8, it says that 8 is of a lower value. So it sorts 12 and 8 first, and then it sorts 9 and 3, and then it sorts 11 and 5, and then 4. And then going to the next merge, we see that sorting 8, 12, 3, and 9, it sorts them in the right order where 3 goes and then 8 and then 9 and then 12. Also the same thing on the right hand side. We see 4 and then 5 and then 11. And then finally it merges everything together in a sorted way. So this is how a merge sort algorithm work. It does this by breaking down and building up the array to sort the array. So it does it recursively, basically. So by divide and conquer, just as we established, it breaks up the array. And then the algorithm merges those small pieces of array back together from the lowest value first, resulting in the sorted array. Um, let's go to the next slide. Okay, so this is just a pseudocode of how it works. So we see here that first condition, if the array is greater than 1, then, it divides it just as we say, divide it into halves, halves, halves. And then we see that this is a recursive function where the function calls itself. So until it gets to a point where it's not less, where it's not greater than one, then it merges everything. So that's how the algorithm works. Um, some of the characteristics of a merge sort, one, we say that it has, basically a constant. It's what I mean is the time complexity is same whether in the best case or in the worst case. So it has a complexity of n log n, the complexity of n log n. And I'm going to just give us a brief explanation on how that is done. So we see first, let's assume we have n number of elements in an array. So what it does is each time you split it into half, it takes a constant time. But this happens in so for every level, right? For um for the number of elements, it divides it into a level of log 2n. So that's the number of levels we have for every number of elements. And when it merges up, merging those two halves takes n number of time. So combining both together, putting it together, the level of recursion is log 2n, so log n raised to power 2, and it works on, it merges using n times, so multiplying those two gives us n log n. So that's how the complexity comes about. Moving forward, advantage of merge sorts. So one is it's a stable sort. What do we mean by it's a stable sort? It means that the merge sort preserves the order. So the order of equal elements. So let's say, for example, two records have the same key, uh, with the same key appear in the same order in the inputs. They will stay in the same order. So as we saw in our example here, let me go, let me go back a bit. I was saying an example. So we see here that 12, 8, 9, and then 3, 11. So when it's merging, you see it merges 12 and 8, 9 and 3, 11 and 5. And then as it combines, then it starts sorting it. So the order of sorting is stable. So let's go back to our advantage. So another one, predictable time complexity. So we've talked about the complexity. It's the time complexity is consistent, which is n log n, both in best, average, and worst case. Unlike, different sort that may have different time complexity. So with this, it helps us in our analysis of the algorithm. It works well with large data sets. So due to its consistent performance and method of processing, it's well suited for large lists and for batch processing. Also, it can be used for external sorting. So when a data is too large to fit into a memory, it is sorting the data from a disk. Merge sort is ideal. You can sort chunks of data in the memory and merge them later. So it makes it suitable for external sorting algorithm. Um, okay, disadvantage. It requires additional memory space. So, by this, Merge needs extra memory, to store the temporal array before the merge process. So this could be a major drawback in merge sort. It's slower for smaller data set compared to simple algorithm like in search sort. So by this, we mean for small lists, merge sort tends to be an overkill compared to simpler algorithms, which could be faster. So for smaller data sets, method may not be the best. Application of mesh sort. So mesh sort is used in certain linked lists. It's used in external sorting, like database, as we said, and large data sets where stability is important. When we talk about um stability, it talks about, is a stable sort, it preserves the order. So in those kind of situations, for example, maybe an application like multi-level sorting, when you want to sort maybe a department, then by name, stuff like that. So merge sort helps in those kind of large data set where stability is of importance. Okay, conclusion. Merge sort is a powerful and efficient sorting algorithm based on its divide and conquer paradigm. It's especially useful for large data sets where stability is of concern. With this, I've come to the end of my explanation regarding merge sorts. If you have any questions or you could reply in the discussion. Thank you very much.